Salam and good day everyone. So for today we are going to learn chapter 6, okay, about data design. So during the system analysis phase, okay, you created a logical model of the system. So for now, you must decide how data will be organized, stored and managed, okay, because these are important issues that affect data quality and consistency, okay.
Okay, so moving on to the data design concept. Okay, so before constructing an information system, a system analyst must understand basic data design concept, including data structures and also the characteristic of file-oriented and DBMS, including web-based database design. So, data structure is a framework, okay, for organizing, storing, and managing data. So, it consists of files or tables that interact in various ways. Okay, so each file or tables, okay, contains data about people, places, things, or event. So, for example, one file or table might contain data about customers, and other files or tables might store data about products, orders, suppliers, or maybe employees. Okay, so basically, depending on how the files and tables are designed, an information system is called a file-oriented system or a database management system, or known as DBMS. Okay, so there are two types of data structure: file-oriented system and DBMS. Okay, so for the file-oriented system, okay, or we call it as a file processing system, okay, it stores data in one or more separate files. Okay, so for example, as shown in this figure, okay, the auto repair shop with two separate file-oriented system. Okay, so a job record system that uses a job data file and employee record system that uses a mechanic data file. So in this example, the job file contains the data necessary to answer inquiries and generate reports about work performed at the shop. Okay, same also with the mechanic file stores. Okay, it stores the data necessary to answer inquiries and also generate reports about the shops and employees. Okay, so from here, you notice that the same data is stored in more than one location. For example, 3 items of information, okay, mechanic number, name, and pay rate, okay, are stored in both data files. Okay, so this redundancy is a major disadvantage of file-oriented system. Okay, because it reduces efficiency and also the data quality. Okay. Alright, moving on to the DBMS. Okay, so in a database management system, all the tables are connected by common field. Okay, so a typical common field might be a customer number, okay, which could be used to locate information about the customer in other table. So a common field that connects two tables is said to link, join, or relate the table. Okay. So now consider this figure. Okay. It shows how the same auto repair shop might use a relational database instead of a file-oriented system in the previous slide. Okay. So from here, notice that the two tables are linked by the mechanic number field. Okay, so this link allows information to be accessed from either table as if the two tables were one large table, making it unnecessary to store the duplicate information. Okay. So, three potential problems exist in a file processing environment. Okay, so the first problem is data redundancy, which means that data common to two or more information systems is stored in several places. Okay, so second one, okay, data integrity. Problems can occur if updates are not applied in every file. And lastly, the third problem is the rigid data structure of a typical file processing environment. Okay, so a file-oriented information system can contain various types of files, okay, including master file, table file, transaction file, and boot or scratch file, security file, and lastly history file. Okay, so basically a DBMS is a collection of tools, features, and interfaces that enables users to add, update, manage, access, and analyze the contents of a set of data. Okay, so the main advantage of a DBMS is that it offers timely, interactive, and flexible data access. Okay. Alright, so a DBMS provides an interface between a database and user who need to access the data. So although users are concerned primarily with an easy to use interface and support for their business requirement, the system analyst must understand all of the components of database management system. So in addition to interface for users, database administrators, and related information system, a database management system also has a data manipulation language, okay, a schema and subschema, and a physical data repository. So moving on to the DBMS component, okay, so users typically work with predefined queries and switchboard commands, but also use query languages to access, store data. So a query language allows a user to specify a task without specifying how the task will be accomplished. Okay, so some query languages use natural language commands that resemble ordinary English sentences. Okay, so for example, query by example, QBE, okay, meaning that the user provide an example of the data requested. Okay, and in other words, okay, many database programs also generate SQL, or known as structured query language, okay, which is a language that allows client workstations to communicate with servers and mainframe computers. Okay, and then for the database administrator or DBA, they are concerned with data security and integrity, preventing unauthorized access, providing backup and recovery, okay, maintaining the database, and supporting the user need or user requirement. Okay. Okay, so this figure lists some major characteristics of web-based database design. Okay, so in a web-based design, the internet serves as the front end or interface for the DBMS. So basically, internet technology provide enormous power and flexibility because the system is not tied to any specific combination of hardware and software. So these are the example of the internet terminology. Okay, so to understand web-based data design, okay, it is helpful for you to review some basic internet terms and concept. Okay. Alright, so for example, this figure, okay, to access data in a web-based system, the database must be connected to internet or intranet, of course. Okay, so when a client workstation requests, okay, a web page, the web server uses middleware, okay, this one, to generate a data query to the database server. Okay, so the database server respond and middleware translate it. Okay, the retrieve data into an HTML page that can be sent by the web server and displayed by the user's browser. Okay, so basically web-based data must be secure, easily accessible to authorized user. So to achieve this goal, okay, you need to well-designed system and provide security at 3 levels. Okay, the database itself, okay, the web server, and the telecommunication links that connect the component of the system. Okay. Alright, so next thing we have the data design terminology. Okay, so first one is entity. So as you all know, an entity is a person, place, thing, or event for which data is collected and maintained. Okay, so for example, an online system may include entities, name customer, order, product, and supplier. So when you prepare or construct DFD during the system analysis phase, you need to identify various entities and also the data store. Okay, and after that, you will consider the relationships among the entities. Okay, so for the table or file, okay, data is organized into tables or files. Okay, so a table or file contains a set of related records that store data about a specific entity. So third one is the field. Okay, so a field, also called an attribute, is a single characteristic of fact about an entity. So for example, a customer entity might include the customer ID, first name, last name, address, city, state, zip, and so on. Okay, so for the record, okay, also called a tuple, okay, it is a set of related fields that describe one instance or occurrence of an entity, such as one customer, one order, or one product. Okay, so there are 4 types of keys, okay, which are primary key, candidate key, foreign key, and secondary key. So for the primary key, it is a field or combination of fields that uniquely and minimally identifies a particular member of an entity. So for example, in a customer table, okay, the customer number is a unique primary key because no 2 customers can have the same customer number, because that key also is minimal. Okay, and it contains no information beyond what is needed to identify the customer. And then, in a customer table, a customer ID might be used as a unique primary key. Okay, so customer ID is an example of a primary key based on a single field. Okay, so for the candidate key, okay, sometimes maybe you have a choice of a field or field combination to use as the primary key. So any field that could serve as a primary key is called a candidate key. Okay, so and next thing we have the foreign key. Foreign key is a field in one table that must match a primary key value in another table in order for you to establish the relationship between the two tables. So lastly, secondary key. So secondary key is a field or combination of fields that can be used to access or retrieve a record. So for example, if you need to access records for only those customers in a specific zip code, you would use the zip code field as a secondary key. Okay, so moving on to the normalization. Okay, so normalization is a process of creating table design by assigning specific fields or attributes to each of the table, okay, in the database. So a table design specifies the field and identifies the primary key in a particular table or file. So while working with a set of initial table design, you will use normalization to develop an overall database design. So during data design, okay, you must be able to recognize a repeating groups of field. So a repeating group is a set of one or more fields that can occur any numbers of times in a single record, okay, with each occurrence having different values. Okay, so a table design that contains a repeating group, we call it as unnormalized design. Okay, so there are few types of normal form. Okay, first one is the first normal form, second normal form, and lastly third normal form. Alright, so moving on to the using codes during system design. So a code is a set of letters or numbers that represent a data item. So codes can be used to simplify output, input, and also the data format. Okay, so during the data design process, okay, you will review existing codes and develop new ones that will be used to store and access data efficiently. Okay, so basically companies will use many different coding methods, okay, because information system user must work with coded data. So the code should be easy to learn and apply at the same time. Okay, so if you plan to create new codes or change existing ones, you first should obtain comments and feedback from the users. Okay, so here are the 7 common coding methods. Okay, sequence codes, block sequence codes, alphabetic codes, and then significant digit codes, okay, and so on. So here are the steps, okay, for the database design. Okay, so you can see this example. Okay, alright, so next thing we have the database model. Okay, so whether traditional or object-oriented development methods are used, the relational database model is universally accepted as the best way to organize, store, and access large amounts of data. So relational databases can run on many platforms, including personal computer. And for the object-oriented databases, okay, many system developers are using OODB, designed as a natural extension of the object-oriented analysis process. Okay, so next thing for the data storage and access, okay. A data warehouse is an integrated collection of data that can include okay, so for the data warehouse, okay, it is an integrated collection of data that can include seemingly unrelated information no matter where it is stored in the company. Because it can link various information system and databases, the data warehouse provides an enterprise-wide view to support management analysis and decision making. Okay. So for the data mining, okay, data mining software could help a consumer products firm identify potential customers based on their previous purchases. Okay. Alright. So physical storage involves a physical record or block. Okay, which is the smallest data unit that can be handled by the OS or operating system. So the system reads or writes one physical record at a time. Okay. Alright, so moving on to the data storage format. Okay, so basically all data are stored in the form of binary digits. Okay, either 0 or 1. Okay, so there are 4 primary data storage formats. Okay, first one binary digit. Okay, ABCDIC, ASCII, and also the Unicode. So for the ASCII, okay, ASCII stands for American Standard Code for Information Interchange. It is a coding method used on most personal computers. Okay, so for the both of these code, okay, it require 8-bit or 1 byte for each character. Okay, so for the Unicode, it is more recent coding standard that uses 2 bytes per character rather than 1. So this expanded SHIM enables Unicode to represent more than 65,000 unique multilingual characters. Okay. Okay, so for the absolute date, okay, it is the total number of days from some specific base date. So lastly, okay, a well-designed DBMS must provide built-in control and security features, okay, including sub-schema, password, okay, encryption, audit tree file, and backup and recovery procedures in order to maintain the data. Okay, so the data control includes user ID, password, backup, recovery procedures, audit log files, and also the audit field. Okay, so file and database control must include all measures necessary to ensure that data storage is correct, complete, and secure. Okay, so that's all. Okay, for this chapter.